Okay, so let's go in order here. So they asked for to find the linear speed. Linear speed's pretty simple. It's just it's no different than if you were just driving down the street. It's just the distance divided by time. And so they give us a distance and they give us a time. Suppose it takes 18 seconds for 56 centimeters of belt to go around the pulley. So that's all you have to do is do that ratio. And I've got my formula over here. So my linear speed is equal to, we're going to go 56 centimeters in 18 seconds. And we need to go ahead and reduce that. So let's see, 18. Or I'm sorry, 56 divided by 18. And then let's see. So that reduces to 28 over 9. So we're going to go 28 over 9. Let's see, we're talking about centimeters per second. And so see, they tell you what they want right there, centimeters per second. So that's all you have to do for linear speed. Now, angular speed, same idea. It's just going to be the angle size divided by time, okay? And so what we have to do, there's a couple different ways you could figure this out. So from part A, what we know, and this won't be drawn to scale perfectly, but what we know is we've got like an arc length right there of 28 over 9 centimeters per second. So I think it was about 3.11 repeating, right? And so that's the arc length per second, right? And so if we could figure out the size of that angle, that's how big the angle is as this turns per second. So every second that goes by, this is the size of the angle I have in my picture right here. So if I could just figure out the size of that angle, I would have my angular speed in radians per second, because my arc is already in per seconds. So what I'm going to do here is, if you were to look back at arc length, which is, we use s as our variable, is equal to theta times the radius. Okay, and so I have two parts of that. I have the radius was given, and I know the arc length from part A. I know the arc length of this angle that's created right here. And this angle is created every second, and that's what we're looking for. That's going to be our answer. That's going to be the radians per second. So I'm going to go ahead and plug in what I know. So I know the arc length is, and I'm going to use the fraction though. I don't want to round till the very end. And then I don't know what theta is, and that's actually what my answer is going to be, because my time is already going to be in seconds. So that's going to be a 1. So that's going to reduce that down to just that my angular speed is equal to theta for this particular example. It's just kind of how it got set up. It was pretty nice. And so let's see, the radius is 13.58. So what I'm going to have to do is divide both sides by 13.58, 13.58. And then that'll give me theta. That'll give me the angle here per second. So let's go ahead. I'm going to put this in my calculator. Clear that out. So let's see, we're going to have, or I guess I could have left it. Let's see, 28 divided by 9. Let me go ahead and press enter. And then we're going to divide that by 13.58. And so that gives me 0.229. And so I'm not sure how much they want us to round. Let's see. 0.229. And I just noticed on the first one it said type an integer or a decimal. So actually I guess we would have rounded this one to the nearest tenth, which would have been 3.1. And so if we're rounding this one to the nearest tenth, this would be 0.23 when you round, if it's the same rounding for both parts. Okay, so I hope that helps, and send me more questions if you got them.